Greetings guests, previously we were focusing on enhancing urban mobility through mobility as a service in a developing country on a high-level perspective. Now we'll be focusing on it a bit deeper in the following categories, which are business architecture, information architecture, technology architecture.
Hi, Francis speaking. What is a business capability module? A business capability module is a popular enterprise architecture artifact used to develop the business architecture. So we're going to utilize a business capability module to develop the business architecture for our mobility as a service platform. But first, who are our stakeholders? Our stakeholders include investors, our employees, suppliers, creditors, regulators, transport partners, and most importantly, our users or customers. The core capability areas, which are the high-level capabilities we identified, are one, that is mass platform management. If we break it down, we're looking at strategic management with our partnerships or transport providers, and we're looking at operations. If we break it further down to lower levels, we're looking at user data capture, real-time operations, dynamic routing for accessibility. Our second core capability area is user experience and engagement. If we go a bit down, we're looking at user acquisitions and onboarding as a capability area. We're also looking at user interface interactions. So in that case, we're looking at an interactive user interface. We're going to incorporate feedback mechanisms to get feedback from our users, and we're also going to have personalized journey planning. Moving on, we have transportation services integration. If we break it down, we're looking at transportation services onboarding and their interoperability. So in that, we're looking at how we integrate our systems with our transport providers. Our fourth capability area is payment and billing management. We're looking at secure payment processing, regulatory compliance, and then we're going to be invoicing for transparency. Our fifth capability area is analytics and optimization. So we're going to look at user behavior data, trip patterns, and we're going to monitor the platform so we can make informed decisions about our customers. We also identified our key business processes as transportation service provider onboarding, booking and planning travel, processing of payment, coordination and integration of services, and reporting and monitoring of performance. Thank you very much. And under there, we've got our references to make our business architecture solid.
So now we're going to discuss the technology architecture of mobility as a service and touch on the different aspects that will be catered for, as well as the tech stacks and the advantages of using these technologies. So what do you think technology architecture is? Desprez and Raymond classify technology architecture as a bridge between application architecture and real-world software and hardware. It ensures that application pieces work together seamlessly by integrating key business processes. The front end is important as it's what the users see and would need to be user-friendly. The use of mobile and web apps would enable accessibility to the users. We've selected React as the tech stack to enable our front end, as it had many advantages that can be seen on the screen. The backend maintains the mechanisms that process data and perform actions on websites. Microservice architecture is key to ensure continuity of the different services within mobility as a service. Java was the chosen tech stack because of the reasons noted on screen. It's key to note that RESTful APIs will enable communication between front and backend. Relational databases like MySQL would be used for storing user data, service provider data, and trip info. NoSQL databases like MongoDB would store large amounts of data for analytics. From a security perspective, regular security checks would be needed and encryption of data, and use of authentication services like SSL and authorization services like OAuth 2. Secure payment gateways that are popular in the South African market include PayU, Ozo, Yoco, and SnapScan. The payment forms that would be accepted would include credit cards, cash, voucher pins, and digital wallets. A cloud platform like AWS would provide scalability, reliability, and economies of scale, saving us money as opposed to investing heavily on physical servers. AWS Kubernetes would work well to help manage containerized workloads and make for easy deployment. Was the content useful? If not, please leave a comment on the YouTube channel.
What is information architecture? Information architecture in mobility as a service is the backbone of a mobility as a service platform, ensuring a smooth and user-friendly experience. It's the art and science of organizing and structuring the vast amount of information within the mobility as a service app or platform, making it easy for users to find what they need, plan their journeys, and complete tasks efficiently. So in our case, we'll be focusing on the different sections under information architecture, which are data models and schemas, data repositories, and security considerations. Under the data models, we have transportation services, users, payments, and transactions. Have you ever thought of how certain services in our everyday lives work? Well, we'll be unpacking that. The transportation services data model is to focus on the service type, service provider, route taken, and vehicle type. Its schema is defining the data types that will be used and relationships between entities. The user data model is to focus on the user details, account, for example, account login credentials, and payment methods, whether using a voucher, debit card, credit card, or cash. Its schema is data types for user information, secure storage for login credentials, and implement mechanisms for user authentication. Payment data model is to focus on the payment amount and currency, payment method, whether using a voucher, debit card, credit card, or cash, and transaction type. Its schema is providing secure methods for storing payment information, complying with Payment Card Industry, PCI, and Data Security Standard, DSS, for security. Transaction data model is to focus on the bookings, unique tickets, the trip, start and end time, and the actual route taken. Its schema is having relationships between transactions. Moving on to the next category, we have data repositories. Under data repositories, we'll be focusing on the two elements, which are data integration and interoperability, and centralized database. Under data integration and interoperability, we have application programming interfaces, also known as APIs. What is an API? API is an application programming interface. It is a set of rules or protocols that enables software applications to communicate with each other to exchange data, features, and functionality. When dealing with databases, you must make sure that it's accessible locally and remotely, and you follow the principles of handling databases. Under centralized database, we focus on standardized data formats. Standardized data is data from different sources that has been transformed into a consistent, standards-based format. The data standardization process involves harmonizing data so that all entries in different datasets that relate to the same terms all follow the same format, allowing them to be compared meaningfully. And data lakes. A data lake is a centralized repository that allows you to store all your structured and unstructured data at any scale. Moving on to our last category, which is security considerations. Under security considerations, we have three elements. Let's just mention them and their uses. That's why we have encryption. In encryption, we encrypt data at rest and in transit to protect user privacy, lock up your data like a secret agent. Secondly, we have access controls. Implement robust access controls to restrict access to sensitive data, for example, payment information. Lock up the treasure chest of sensitive data with top-notch access controls, like guarding precious payment info. Lastly, we have data security. Regularly monitor data security and conduct vulnerability assessments to keep a close eye on your data's safety and give it a regular health checkup to keep those cyber baddies at bay. What we've learnt in this task is that information architecture requires comprehending the user's needs and goals, and that a well-designed information architecture forms the foundation for a user-friendly mass application. In conclusion, a strong information architecture plays a crucial role in making mobility as a service platforms efficient and user-friendly.